Okay. Hi everyone. Today I have just brought this question which was given to me personally by one of my students, and if you can just read the entire question, there is a lot of data given in this uh, question, and you can just pause the video and go through the entire question in order to get the theory behind that. However, I have made my efforts in order to put the data into a tabular form. So if you have gone through the question, you will understand that there is a thin tape here, and this tape is wound up on the entire spool, and the inner radius of the spool is given as 10 mm, the outer radius is 25 mm, and when you have completed the spooling, the length of the entire thin tape is 70 meters, and the time it takes is 165 seconds. Now in the second case, what they have said is that okay, this same machinery, this same spool, same thin tape is utilized only for 110 seconds. So earlier it was for 165 seconds, now they are using only for 110 seconds. So the inner radius will not change because there is some spool on which we are winding it up. So this is not the part of the thin tape. Thin tape starts from here and it goes outward. So the inner radius does not change. However, the outer radius would change, but right now we don't know the exact value of the radius, how much it is going to wind up. Same is with length as well. We don't know how much length it is going to wind up with the thin tape. So this is the question where we are supposed to find out the length of the tape which is getting wound up for 110 seconds. And one more data is given is that okay, they are saying that okay, the angular velocity is constant because the machinery is same, so the winding rate is same. So this actually signifies the radius which is just increasing from this part to this part would be linearly dependent on time. So anyway, we'll come to that part in some time. Now, just to make you understand what this rectangle thing is, I have just considered that this is my thin tape, this is my thin tape, and whose thickness is, let's say, x, and the length is L, that is the 70 meters. So if this tape was not wound and it was just straight tape, it would have gone to 70 meters. And when it was done for 110 seconds, the length would have been something else, and I'll call that small l. However, the thickness would remain same. And the length, if you see, if you compare this length and this length, the length is shorter. So it's just the spool getting opened and the entire tape is straight. Now, there are two parts to this. Like there is two things which are unknown, that is length and the radius of the spool. We want length, but in order to find out length, we may require r. Let's see. So to start with, just try to analyze here. Okay, the area which I am shading over here in laser, this area would be equal to the area occupied by the entire tape, because this tape is wound up on this. So obviously this area would be equal to the area occupied by this thing. So this is a circle, and we can just this is a cross section of a cylinder, so we can just say that pi r outside square minus r inside square. Now this is the area of this shaded region. I'll just highlight that. Pi r0 square, that is the full square, full circle ka area minus the inside area. So you'll get this area. This is equal to the area of this shaded region, which is just a rectangle kind of cross section. So I'll write as length into breadth. So length is L, breadth is X. Also, if I do the same thing for this another case, so this shaded region would be pi r square minus pi r inside square. this area would be equal to the area of this thin tape. So it would look similarly, pi r square minus r inside square equal to the length into the breadth. Now this is my equation number 1 and this is my equation number 2, and I'm going to divide these two equations in order to find out either L or R. So let's say the second equation divides with first equation. So I'll get pi r square minus r inside square divided by pi r0 square minus r inside square equal to Lx upon Lx. Now the pi can get cancelled, x can get cancelled because the thickness is same. I'll put in the values, whatever values I have. R is unknown, right now I don't know the value of R. Inside is 10 square upon outside is 25 square minus inside is 10 square equal to small l is unknown but capital L is 70 meters. So whatever values I wanted, I have just picked up from here. So you can just pause and look out for any values. Okay, now let's deduce what we can here. R square minus 100 divided by 625 minus 100 equals L by 70. So R square minus 100 divided by 525 equal to L by 70. I can also write this as R square minus 100 upon 52.5 equal to L by 70. Now if I cancel this, 7, no, I made an algebraic mistake. So if I shift the point in this case, I'll get a 7 over here. I have just moved the decimal from one place to another place, something like this. I have moved the decimal from here to here. This decimal goes from here to here. I can also cancel this. So 7 ones are 7, 7 sevens are 49, and 0.5 is 35. So my equation turns out to be L is equal to R square minus 100 divided by 7.5. So this is one of the equation in which I have two unknowns. So we need some value of R in order to get the value of L. Okay, so now my next struggle would be for finding out the radius of the spool, that is this part, this radius, this part R. Okay, so if I want to find out this radius R, I can just use an analogy somewhat like this. It is R0 minus Ri, that is outside minus inside, is equivalent to time t. Equivalent to time t, I mean to say that when you are filling this much amount of thread by just rotating the entire machinery, entire spool, it takes a time of 165 seconds. So R0 minus Ri is done in 165 seconds. So R minus Ri would be done in 110 seconds. So it goes like this. If I can fill R0 minus Ri in time t, then I can fill R minus R inside in time small t. This is just a cross multiplication kind of stuff, where I have just used this analogy. Okay, if I am trying to fill this much amount of thread or tape in this much time, then I'll be filling this much amount of tape in this much time. So I've just used that analogy, and let's see if I am able to cross multiply and get the value of R here. So r0 minus ri into t equal to t times r minus ri. R0 is 25 minus 10, T is 110, capital T is 165, R is unknown, and this is 10. So this would be 15 times 110 divided by 165 equal to R minus 10. So this will give me 15 ones are 15 11s are, and 11 ones are 11 10s are. So that is 10 plus 10 equal to R. So finally I am getting R is equal to 20 mm. So since I have the value of R now, I can substitute that value, this value, over here in the equation of L. So let's do that and try to get this. So my equation is L equal to R square minus 100 upon 7.5. Just let me check if I'm not wrong. R square minus 100 upon 7.5. Yeah. So L would be equal to R is 20 minus 100 upon 7.5. 20 is square is 400 minus 100 upon 7.5. This goes like 300 by 7.5. I'll multiply this by 2, multiply this by 2. So that will give me 600 by 15. That will yield me 40 meters. So the length comes out to be 40 meters. So my student has not given me options over here, but even that would have been, I guess that's a correct answer. So I hope you found out this explanation easier, and in case if you're finding out easier, you can just subscribe to the channel and wait for a few more videos. Thank you so much.